Hey guys, Mr. Bowman here. Today's learning objective is in green and we're learning to use probability trees to solve problems. And probability trees are something that we'll be familiar with from previous years. But this time around there's going to be a bit of a twist and we're going to try and link some new concepts with our probability trees. So the first step we got, let's have a thorough read of our question. So Pukemahi High School is analysing this data in relation to Year 13 students. Year 13 group comprises of 52% females and 48% males. The probability of a male studying Year 13 calculus is 41%, whereas the probability of a female studying Year 13 calculus, 29%. So we've got a whole bunch of numbers, so 52%, 48%, 41%, 29%. And the first question asks us, complete a probability tree in relation to the data that we're looking at. So question A. And hopefully at this time, I'm just going to recap some probability concepts as we're doing it. So a probability tree comprises of two events. So event 1 and event 2. And in our case, we've got to think, well, what two events are occurring based on the numbers we've been given? And the first event, well, it looks like we're trying to figure out, well, is the student in question a male or a female? And if they're a male, do they take calculus or not calculus? And then the same with females, calculus and not calculus. From there, we can then add on the probabilities of each event. So the probability of a male, well, that was 0.48. And the probability of a female, that was 0.52. And then we can carry on with the calculus one. So the probability of a male studying calculus was 41%. So that there was 0.41. And we've also been told the probability of a female studying calculus was 0.29. And I suppose the first step that we need to do is, hopefully we've noticed that the first branch, 0.48 plus 0.52, that comes to 1, which means we can use that information to find out what the not calculus numbers are. So what that number and that number would be. So 1 minus 0.41, that's going to get us to 0.59. And then 1 minus 0.29, well, that's going to be 0.71. We then need to consider all of the combinations. So the first branch, that's the people who are male and studies calculus. Then we've got male and not calculus, female and calculus, and then female and not calculus. From there, we can find the probability of each of those branches. So the probability of each branch, 0.48 times 0.41. And then we've got 0.48 times 0.59. And then we've got 0.52 times 0.29. And then 0.52 times 0.71. From there, we can calculate the probability of each branch. So the probability would be 0.48 times 0.51, 0.1968. And then we've got 0.48 times 0.59, 0.2832. And then we've got 0.52 times 0.9 or 29. That there is 0.1508. And then finally, we've got 0.52 times 0.71. And that gets us to 0.3692. And then that concludes our first one, complete the probability tree. We've done that. We're then going to change pen colors. Let's move to green. And we're going to move on question B, which is just a reminder that the probability tree approach we took, we can actually use that information and make it look like a table. So let's draw the beginning of a two-way table. Okay, so let's say the first event, that would be over here. So event 1. And event 1 was figuring out if they were male or female. And then up the top, that would be event 2. And then that is calculus or not calculus. And this box here, males who studied calculus, well, that's our first probability in our branch. So 0.1968. And the probability of males who not doing calculus, well, that's going to be 0.2832. And if you add those together, 0.1968 plus 0.2832, we get 0.48, which makes sense given we were told there were 48% of males. We then can do the same for the female data. Females who do calculus, that's 0.1508. And then the females who don't do calculus, 0.3692. And if we add those together, that should get to our female total. So 0.1508 plus 0.3692, that gets us to 0.52. And that makes sense given we were told there were 52% females. The totals add up to 1 going down. And we can then figure out, well, what's the probability of someone taking calculus? So that there would be 0.1968 plus 0.1508. And that is 0.3476. And we can then find out the probability of someone not taking calculus, 0.2823 plus 0.3692. And that gets us to 0.6524. And we should be able to check these two here. They should be able to add together to get that 1. So let's double check that. 0.3476 plus 0.6542. That gets us to 1. So we're happy with that. Okay, so we've now done our probability table. We'll switch pen colors and we're going to actually get into the questions now. So first question, calculate the probability of a random student taking year 13 calculus. So in terms of our notation, we're trying to find the probability of someone taking calculus. And for this type of question, I encourage us, we still need to use our F over T approach. And we can do this one of two ways. We can just look at our table number, so 0.3476 is what we're looking at, or we can use our numbers from the probability tree. So let's have a look at the tree. Do these people take calculus? Yes. These guys don't. These guys do. These guys don't. So if we add together those numbers, those are our favorables. So that's 0.1968. We're going to plus 0.1508. And that's divided by a total, which is all outcomes, so that'll be 1. And when we add both of those up, that does get us the number from our table. So that means the probability of someone taking calculus will be 0.3476. So if you are going via a table, you can use that number. Or if you're going via a probability tree, you can use either or the numbers or the addition of the groups that we're interested in. So now let's move on to question D. So what percentage of year 13 students are boys or taking calculus? So in this case, we're doing, well, what's the probability of boys or calculus? So same deal as before. Let's get rid of our ticks. We need to go through our criteria, our branches, which of them meet the criteria we're interested in, and which of them don't. So does this top group, are they boys or take calculus? Yes, they are. They're males. Are these boys or take calculus? Yes, they are. They're males. So we've got that, but we don't have the calculus one, but that's all right. These ones here, they are females and take calculus, so they are a tick. They've met one of the two criterias. And the bottom ones across, they're not males or boys, and they don't take calculus, so we're not interested in those. So the probability of being a boy or taking calculus would be the addition of those 3 branches. And when you add them up, so that should be 0.1968 plus 0.2832 plus 0.1508. And when you add all of those up together, you get 0.6308. So we've already done C, we've just done D. Let's have a look at question E. How many times more likely are year 13 boys to take calculus when compared with females? So this is a relative risk type question, whereas we're going to divide, well, what's the probability of someone taking calculus given they are a boy divided by the probability of someone taking calculus given that they are a female. And I keep writing B, but by that I definitely mean M as well. And those numbers were given to us in a question. So we've been told boys or males are 41% of them are going to take calculus. So that there is 0.41. We've been told females 0.29. And when we do that, it'll tell us how many times more likely males are to take calculus when compared with females. And that gets us to 1.41. And I rounded that to 2dp. And then finally, question F, we've been asked to summarize this information for the Pukumahu High School headmaster. And there's a few bits of information that we need to summarize. So there are more females in year 13. Than males. Males are 1.41 times more likely to take calculus than females. So I think those are the two bits of information we'd want to be going over. So we want to figure out who's more likely to occur, males or females, and are males more or less likely to take calculus than females. So guys, hopefully you found this video useful. So we looked at probability trees. We then linked them to two-way tables. And then from there, we did a couple questions involving using the table to find the probability of certain events. We then went a little bit extra. We did some relative risk. And then at the end, we did summarize the information that we've been looking at for the headmaster of the school. So hopefully you found this video useful. Now let's get into heaps of practice.